Hi students, welcome to Deductive Geometry Part 3. Okay, let's talk about Euclid again. A famous quote from Euclid is this one: "Sire, there is no royal road to geometry." He said this to Ptolemy I, who was the pharaoh of Egypt at the time. The pharaoh had sponsored Euclid to write his textbook, but was having trouble understanding it. And when he asked Euclid to explain it to him or make it easier, Euclid's response was, basically, there is no shortcut to understanding it. It's going to take perseverance and time and effort. So our goal for today is to understand and apply the rules for identifying similar triangles. You will know you're successful if you can remember and apply the 4 rules to identify whether triangles are similar. And this is because geometry is important for many fields, including construction and engineering. Similar figures. Two shapes are similar when one is an enlargement or a reduction of the other shape. Okay, so the symbol for similar figures is the wavy line, and that means it's similar to. Alright, so if we look at our diagram down here, we've got an object, alright, that is a triangle. And up here, we've got an enlargement of the object, so we call that our image. Alright, now if we compare two sides on our triangles, right, so if we compare the length of this side here, our image length, let's say that was like 6 centimeters. If we compare that with our object length, which let's say that's 2 centimeters, right? Let's write that down. All right, so if we compare, what do we say, 6 centimeters for our image length and 2 centimeters for our object length, 6 divided by 2 is 3. So our scale factor for these two images would be 3. Similar triangles. Two triangles are similar if they have the same angles or if the corresponding sides are proportional. All right, so in our triangles here, we've got, let's compare the two hypotenuse lengths. So if we went 10 divided by 5, that's going to be 2, give us the answer of 2. That will be the same if we go 6 divided by 3. Okay, so that other side's, the other side's in proportion. And if we went 8 divided by 4, all right, they are all in proportion. The scale factor is 2. Testing triangles for similarity. Right, so before when we looked at congruence, there were 4 tests for congruency. Let's just quickly do a review. So there was the angle, angle, side rule. There was the side, side, side rule. There was the SAS rule, the side, angle, side rule, and the RHS rule. Okay, so the rules for testing triangles of similarity are very similar. Okay, we use these rules, but in a slightly different way. So for our SSS test, again, we're looking at comparing the 3 sides, but this time we're seeing whether they are in proportion. Okay, so we compare side A, and the scale factor is K, all right? So this side is K times larger, all right? Comparing side B and with side B, that is K times bigger, and side C with side C, that is K times bigger. Right, now K could stand for any number. I reckon just looking at this, I reckon it would probably be about 2 times bigger, right? So each side has been, is twice as large as the sides in the first triangle. Now I want you to work out which of these 3 triangles, which 2 are similar. So pause the video and have a go. Alright, so the first thing I would do would be to compare my smaller side of the triangle. So I'm just going to pick, wouldn't really matter, just choose whether it's the biggest side or the smaller side. I'm going with the smaller side. So triangle 1, its length is 2. Triangle 2 has a length of 2. Okay, now I can see, looking at the 2 triangles, that these 2 are not going to be similar, right? Because they're not in proportion. In fact, they're the same size, and yet on our other sides, they're different. Okay, so for example, in the first triangle, our longer side is 4, and triangle 2, our longer side is 5, right? So the other sides are getting bigger, and the smaller side is staying the same. Therefore, triangle 2 cannot be similar to triangle 1. All right, so let's compare 1 and 3. Let's compare the shorter side again. All right, so triangle 3, our shorter side is, oh my goodness, our shorter side is 3. Triangle 1, our shorter side is 2. 3 divided by 2 gives us 1.5. Right, let's compare our hypotenuse, or not our hypotenuse, our longer side, right, which is 6. Let's compare it with the longer side on triangle 1, which is 4. Right, go 6 divided by 4. That also will be 1.5. So that's the same scale for those two sides, but let's just check the third side. So 4.5. So let's compare our remaining side, 4.5 divided by 3. So what I'm doing is comparing the lengths of the corresponding sides. All right, we went with the shorter side to the longer sides, and then the ones that were left, okay, so the leftover sides. All right, and they all add up to all equal to 1.5, right? So our scale factor of triangle 1 and triangle 1 is similar to triangle 3 because of the side, side, side rule, and our scale is 1.5. Okay. The AAA rule is that two angles of a triangle are equal to two angles of another triangle. All right, so this implies that the third angle is the same because we know that the sum of interior angles in a triangle is 180. All right, so in our two triangles, this angle is the same as this angle, and this angle is the same as this angle. So therefore, we know this angle and this angle are the same. All right. Now, I'd like you to calculate which of the two triangles below are similar. Okay, so pause the video and have a go. So the first thing we need to do is work out what is the angle here. So we know from our interior angles of a triangle rule that 40 plus 60 plus our missing angle, which we'll call A, equals 180. Oops. All right, so A will equal 80 degrees. All right, over here we can see straight away that it's not going to be the same. All right, if I calculate angle B, all right, B plus 50 plus 60 equals 180. So I'm going to work out that B equals 180, take away 60, take away 50, it will equal 70 degrees, okay? So straight away I know triangle 1 and triangle 2 are not congruent. So let's have a look at triangle 3. All right, it's got two angles that are the same, 40 and 60. All right, 40 and 60. So we know that the third angle is going to be the same, which is 80. All right, so we can say that triangle 1 is congruent. No, we're not doing congruent. Is similar. Oops, let's just, hang on, I'll just change that. That's my bad. Is similar. All right, we're doing similar. This one is similar to triangle 3. Okay. The SAS test is that two sides of a triangle are proportional to two sides of another triangle and the included angles are equal. All right, so let's have a look. We've got side A and side on the second triangle that's K times bigger than A, right? K could just be any number, right? Side C is K times bigger on the second triangle, and then our included angle here is the same in both triangles, right? So we've got a side that's proportional in both triangles, the included angle is the same, and then the second side is on the other side of the included angle is proportionally bigger in the second triangle. All right, so that's the SAS rule. The important thing to remember in this one, same as in congruent triangles, the A has to be the included angle. I'd like you to find a pair of similar triangles from the three below and give a reason for your answer. So pause the video and have a go. Okay, so we've got an angle that's 140 degrees here and here on triangle A and B. Let's see if the two sides on either side of the included angle are the same in the same proportion. So what I mean is, let's have a look at the bigger side on triangle A compared to the larger side on triangle B, right? So we're going to see what is the ratio, or what is the proportion of the triangle. So 6 divided by 3 is our ratio. Let's compare the two smaller sides. So 4 divided by 2. 4 divided by 2. Does 6 divided by 3, does that equal 4 divided by 2? And it does. All right, so the two sides are in proportion and the included angle is the same. So we can say triangle A is similar to triangle B because of the side angle side test. All right, if we were to have a look, just for argument's sake, at our third triangle, triangle C, right, our included angle is 40. If we were to compare our longer side, so 5 centimeters, divided by, let's compare that to the long side in triangle A, which is our 3 centimeters, 5 divided by 3. Let's compare that to the two shorter sides, 3 divided by 2. All right, so 3 divided by 2. 5 divided by 3 does not equal 3 divided by 2. Therefore, triangle A and triangle C are not similar. Okay? The RHS test is that the hypotenuse and a second side of a right angled triangle are proportional to the hypotenuse and a second side of a right angled triangle. Okay, so having a look at our two triangles here, they both are right angled triangles. Okay, the hypotenuse in a larger triangle is k times bigger than the hypotenuse over here, and it is k times bigger than the shorter side. Therefore, these two triangles are similar because of the RHS rule, or test, sorry. I'd like you to work out which of the two triangles below are similar. So pause the video and have a go. All right, so we've got some right angle triangles. So let's see if the hypotenuse is in proportion. All right, so if we went 5 divided by 5, is that equal to 4 divided by 3? All right, so our two short sides. Clearly it's not. Okay, so triangle 1 and 2 are not similar. Let's compare though, for argument's sake, let's have a look at the hypotenuse of 3, which is 10. Let's compare that to the hypotenuse of 1, all right? So 10 divided by 5, does that equal the two shorter sides? So 6 divided by 3. Yes, it does. 10 divided by 5 is 2, and 6 divided by 3 is 2. Okay, so our two sides are in proportion, and it's a right angle triangle. Therefore, we can say that triangle 1 is similar to triangle 3 because of the RHS rule. The two triangles shown at right are similar, so find the value of x and y. Okay, so we know if they're similar, they will have the same angles, but the sides will be in proportion to each other. All right, so here's two angles that are the same, and this one's 20 degrees. That means that x will have to be 20. X equals 20. Okay, so what we'll do now is have a look at our sides and see what is the scale factor between the two triangles. Now I'm going to circle the two sides that are proportionate to each, or that correspond to each other. All right, and 9 corresponds with y. All right, so an easy way to do it would be to look at the triangle on the left and say, what is the scale factor? How do we get from 4? What have we done from 4? All right, this number here, to get to 1. All right, so we've divided 4 divided by 4 will give us 1. So if we go 9 divided by 4, we'll do the same thing on this one, will give us what y equals. So y will equal 9 divided by 4 equals 2.25. Okay, another way of doing it, because sometimes you won't have such an easy scale factor as just dividing by 4. So let me show you just a different way of doing it. okay, which looks a little bit harder. Sorry, let me just clear. I'm just going to edit, get rid of all that. Okay, so another way to do it would be to compare the sides that correspond, right? So we're going to compare this side and this side. Let's make it in a fraction. 4 divided by 1 is going to be equal to, all right, so 9 divided by y. All right, so let's just color code that so you can see what I just did. Highlighter, we'll make this red. All right, so this side is our 4 divided by 1. Let's make that triangle orange. All right, 4 divided by 1. So we've compared the sides that correspond. All right, we're going to compare that to 9, okay, divided by y. And I guess the important thing that I'm trying to draw out of here is that you have to make sure that, so in our red triangle, the red numbers, okay, are at the top, and then in our orange triangle is what we're dividing by, okay? So we're working out the scale factor for each of the sides, all right? So this was our shorter side that we're compared with our, look, we'll just call this our medium side, okay? It's the corresponding side anyway. All right, so we've got a fraction anyway. So we've got 4 divided by 1 equals 9 divided by y. All right, to work out what y equals, we're going to multiply the bottoms by the top. So 4 times y equals 9 times 1. So 4y equals 9. All right, we're going to divide both sides divided by 4. So y equals 9 divided by 4, okay, which equals 2.25. Question A. Why are the two triangles at right similar? All right, so the first thing I would do is notice that there are parallel lines. So therefore we can use our alternate angle rule, okay? And from that, we can see that this angle here, which I'll just mark like that, is the same as this angle here, right? And this angle here, which I'll mark like this, whoops, with 2 lines, is the same as this angle here. The other thing that we can see is that we've got the opposite angle rule happening just here. So we can say that this angle, we'll put it 3 lines, is the same as this angle. All right, so we've got 3 angles the same in both triangles. Therefore, we've got triangle PQR is similar to angle TSR. Okay, so now we need to find the values of x and y in the diagram. All right, what I might do is just change my pen color a bit. All right, so this angle that's got this angle here, right, this one that's got just there, the side opposite is 3 length long, and the corresponding angle, right, is here. The opposite side is 6. So we know 6 and 3 are corresponding sides. Okay, so we can work out what's the ratio between them. 6 divided by 3 equals 2. Our scale factor from this triangle to this triangle is 2. All right, so now we need to work out what are the 2 other corresponding sides. All right, so if we were to, again, I'm going to change my pen color because it's starting to get a bit messy here. All right, this side here, all right, we said is opposite y, all right? So the corresponding angle is this one here we marked. Remember we said that they are alternate angles here and here, so they're the same. All right, so the opposite side to this one is 8. Therefore, 8 and y are corresponding sides, all right? So we want to know what y is. If 8 is one side, what is y? If the scale factor is 2. All right, so we can do a bit of algebra and change this fraction around. So if we multiply this, we'll end up with 8 equals 2y. Y equals 8 divided by 2, okay, equals 4. All right, so y equals 4. Now, the other one we need to work out is if one side equals 1.5 and x is the corresponding side, we know that's the last two sides that are left. All right, what divided by 1.5 will give us the answer of 2? Our scale factor is 2. All right, so we multiply the bottom. X equals 2 times 1.5 equals 3. All right, so x equals 3. And we can check that. All right, 1.5 times 2 will give us 3. 4 times 2 will give us 8. And 3 times 2 will give us 6. So how did you go in your learning today? Can you remember the formula to calculate scale? So scale equals our image length over our object length. All right, so our object length, remember, is our original size of our object before it's enlarged or reduced. And our 4 tests for similar triangles, we've got the side, side, side. The 3 sides are in proportion. We've got our side, angle, side, where 2 sides are in proportion and the included angle is the same. We've got the angle, angle, side rule, where 2 angles are the same and 1 side is in proportion. And then we've got our RHS rule, where it's a right angle triangle and our hypotenuse and a shorter side are both in proportion to the second triangle. All right, guys, I hope you enjoy your week. If you have any questions, please email us. We'd be really happy to give you a hand.